Now I want us to discuss trigonometry, and I would like us to start by angles between 0 degree and 360 degrees, which make the four quadrants. Angle at a point, angle of a circle. Before we go into our discussion on angles between 0 and 360, I would like us to understand this, that in trigonometry, the word or the concept of quadrants is always a concept that cannot be forgotten. The concept of quadrants and the concept of right-angled triangles. I would like to use this medium to remind you of the trigonometrical ratios and their relationships to the sides of a right-angled triangle, the SOHCAHTOA. Maybe you have heard about this. Maybe mentioned by your teacher or mentioned by an author. Or however, SOHCAHTOA means that sine, which is the first concept of the trigonometrical ratio, is calculated from opposite over hypotenuse. Cosine, C, is calculated from adjacent over hypotenuse. Tangent, represented by T, is calculated from opposite over adjacent. This should be TOA. This should be A. Opposite over adjacent, that is your tangent. In trigonometry, our angles as related to the trigonometrical ratios have values, either negative or positive. And for an angle to have a negative or a positive value, it doesn't come from the Jupiter. It doesn't come from the Mars or Pluto. They came from here, the Earth, and they came from mathematical principles and formulae. So I want to use this opportunity to teach you how to know if an angle given to you should be a negative or a positive valued angle. Now, that idea will come from our quadrants. The quadrant is the relationship between the vertical axis, which is the y-axis, and the horizontal axis, which is the x-axis. In any of them, the measurement of the angle starts from the horizontal axis, which is the x-axis, and moves anti-clockwise until it comes back to where it started after it had made a complete circle, which is 360 degrees. But as it leaves this horizontal axis and moves, before it gets back to where it started, making a complete revolution, it must have passed series of angles. And those angles are the angles you find in the first quadrant, which is 90, in the second quadrant, which is the second 90, 180, in the third quadrant, which is the third 90, making it 270, and in the fourth quadrant, which is the fourth 90, making it 360. So assuming that this angle started from 0 here and moves, remember that this y-axis from the point of intersection up, all the values you have here are positive. But from the point of intersection down, all the values you have here are negative. Likewise, from the point of intersection towards the right, all the values you have here are positive. From the point of intersection here towards the left, all the values you have are negative. Bearing this in mind, we are going to know in between the three trigonometrical ratios we have, sine, cosine, and tangent, which of them are positive or negative in the four quadrants. This is the first quadrant. This is the second quadrant. This is the third quadrant. And this is the fourth quadrant. As I said earlier, it moves anti-clockwise. Now, the angle of, or the triangle, the right angle triangle from where you deduce whether the trigonometrical ratio is negative or positive must have its base on the horizontal axis, which is the x-axis. So the triangle is always in this form. Having its right angle like this. This is the right angle triangle of the first quadrant. And the angle we are talking of is always at this place. Now, we said that sine is opposite over hypotenuse. So let's write sine. Opposite over hypotenuse. The opposite of this triangle is representing the positive side of the y-axis. The hypotenuse in all the quadrants is always a positive value. It is only the opposite or the adjacent that might vary depending on the quadrant. But the hypotenuse, the side of the triangle opposite the right angle, is always a positive value, or is always wearing a positive value. So in this case, the opposite of this our theta, if we are looking for opposite over hypotenuse, the opposite is representing this positive side of the y-axis. So opposite positive over hypotenuse, that is always positive, will give you positive. That means positive divided by positive will give you positive. So sine in the first quadrant is positive. First quadrant. Sine is positive in the first quadrant. Now let's look for cosine. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. If you come to the same triangle, you find out that the adjacent of this angle is this side. And this side is representing the positive side of the x-axis. You will discover that it is going to be the positive adjacent over the positive hypotenuse, which will give you positive. That means the cosine is also positive in the first quadrant. Let's look at the tangents. Tangent is opposite over adjacent. Opposite, positive side of the y-axis, over adjacent, positive side of the x-axis. Positive dividing positive will give you positive. That means tangent also, which is opposite over adjacent. Opposite over adjacent is also positive in the first quadrant. So that is all about the first quadrant. That means all the trigonometrical ratios are positive on the first quadrant. All of them. Now, let's go to the second quadrant. Second quadrant triangle is in this form. Now the theta is here. If you find sine, sine is opposite over hypotenuse. The sine of this angle is opposite over hypotenuse. The opposite is representing the positive side of the y-axis. So we have plus dividing plus. The hypotenuse is always a positive. Positive dividing positive will give you positive. That means our sine in the second quadrant is positive. Now let's go to cosine. Cosine is adjacent over hypotenuse. This is the angle. The side adjacent is here, and the side hypotenuse is here. The adjacent is representing the negative side of the x-axis. So we have negative dividing positive, which will give you negative. That means our cosine is negative in the second quadrant. Let's look at tangent. Tangent is opposite over adjacent. Opposite, positive, over adjacent, negative. Positive dividing negative will give you negative. That means our tangent is negative in the second quadrant. Now let's go to the third quadrant. The triangle of the third quadrant will be in this shape. And the theta will be this place. Sine, opposite over hypotenuse. Opposite, representing the negative side of y-axis. Over hypotenuse, which is positive. Negative divided positive will give you negative. That means our sine is negative in the third quadrant. Let's go to cosine. Cosine is adjacent over hypotenuse. Cosine, adjacent over hypotenuse. The adjacent is representing the negative side of the x-axis. Hypotenuse is always positive. Negative divided positive will give you negative. That means our cosine is also negative in the third quadrant. Let's go to tangent. Tangent is opposite over adjacent. Opposite, negative side of y-axis over adjacent, negative side of x-axis. Negative dividing negative will give you positive. That means tangent is positive in third quadrant. The last is the fourth quadrant. The triangle of the right angle triangle of the fourth quadrant will take this shape, where the angle theta is here. So let's go and find our sine. Opposite over hypotenuse. This is the angle. Opposite, representing the negative side of y-axis, over hypotenuse, which is positive. Negative dividing positive will give you negative. That means our sine is negative in the fourth quadrant. Let's find cosine. Adjacent over hypotenuse. Adjacent, the side, the positive side of the x-axis, over hypotenuse, which is always a positive. Positive dividing positive will give you positive. That means cosine is positive on the fourth quadrant. The last now is the tangent. Tangent is opposite over adjacent. Opposite, the negative side of the y-axis, over adjacent, the positive side of x-axis. Negative dividing positive will give you negative. That means tangent is negative in the fourth quadrant. This now shows us that in the first quadrant, all the trigonometrical ratios are positive. And that is why you see A attached to the first quadrant. Now in the second quadrant, let's check. It's only sine that is positive. cosine and tangent are negative, that means you are going to have S here, signifying that only sine is positive in the second quadrant. Let's check the third. In the third quadrant, it is only tangent that is positive. So we're going to put T here, signifying that only tangent is positive in the third quadrant. Then the last, it is only cosine that is positive on the fourth quadrant. That means we're going to put C here, signifying that only cosine is positive on the fourth quadrant. If you look at the letter now, it will be ACTS, and that will give you ACTS. Or if you want to go CAST. So let's take A from the first quadrant, C from the fourth quadrant, T from the third quadrant, and S from the second quadrant. This means all is positive in the first quadrant. A. C means only cosine is positive on the fourth quadrant. T means only tangent is positive on the third quadrant. S means only sine is positive on the second quadrant. When we'll be discussing about angles or finding the values of angles, it will help us to know whether we should attach a positive or a negative value to any angle we are to find its value. So you are going to realize that whichever value we are attaching to any angle, we did not manufacture it. It is from this concept I have explained to you now. That is where the values of angles must be derived from. So when we go into solving problems, as we are entering into the concept of trigonometry proper, when I will be extracting values for angles, you will really know why I do so. After the discussion of how to attach sines to angles, the next thing we need to also understand is how to find the equivalent angles that we can find from our four-figure table from the different quadrants. For instance, this is our quadrant, and this is divided into 4 right angles. The first one, as we had before, has this angle as theta. From the beginning of the counting of angles till the end of the first quadrant, remember this is the first quadrant, all the angles you find inside are between 0 and 90. You can find them straight. You don't need any conversion. You can find their values here. We call them acute angles. So in the first quadrant, theta is equal to theta. No application of any law. No conversion. No searching for equivalent angles. No. But when the angle must have crossed the first quadrant and entered the second quadrant, that means the angle is this. Just like triangle we drew before. This is the angle here now. It is this angle of this right angle triangle in the second quadrant that is representing all the angles you will find in the second quadrant. Remember, this is second quadrant. Now, if you want to find this angle here, theta, it is going to be the angle from here to here. minus the angle from here to here. The angle from 0 through this place, which is angle on a straight line, which is 180, minus the angle from here to wherever the angle stopped in the second quadrant. It may be this place, it may be this place, it may be this place, it may be this place. Wherever it stops, subtract that its angle from the complete angle of 180. That gives us that the formula or the law applicable in the second quadrant is 180 minus theta. This is always the law you use in finding the equivalent acute angle of the angle that is above 90 but within the range of 180. That is the angle you find in the second quadrant. Now, in the third quadrant, this is your triangle again. Remember I told you all the triangles have their basis on the x-axis. So this is the theta now. This theta is the angle from here 0 through all these places and stop here. It stopped here. That is your theta. And its equivalent angle in the third quadrant is the angle of this triangle. Now, if you want to find the angle of this triangle, what you're going to do is the whole of this angle, which is your theta, which equivalent is the one you have inside here, minus the whole of this angle from here and stopped here. So from here to wherever the angle stops, minus from here to here, we give you here. So it is now theta minus from here to here is 180. So the law applicable on the third quadrant is theta minus 180, the opposite of the law obtainable in the second quadrant. Without wasting much time, let's calculate or find the law applicable on the last quadrant, which is the fourth. This is the third quadrant. So here is the fourth now. In the fourth quadrant, the angle we are looking for is this. Now, from this place to this place is the theta. Is that angle that is within the fourth quadrant, above 270, but not exceeding 360. Now, this angle now, its equivalent angle is the angle inside the triangle. Remember, the equivalent angles have been the angles of the right angle triangles in all the quadrants. So if you want to find this angle now, it is going to be the angle from 0 through all the quadrants to 0 back, minus the angle from here to here. If you want to find this angle now, the complete circle angle minus the angle from here that stops here. So this is giving now the complete circle angle is 360. That is where we are going to derive that the law on the fourth quadrant is 360, the angle of the complete circle, minus whatever the theta is. So you are also going to memorize these laws of the first quadrant. Theta is theta. Second quadrant, 180 minus theta. Third quadrant, theta minus 180. Fourth quadrant, 360 minus theta. They are going to be very, very applicable when we go into solving problems in our trigonometry. The first question we have says we should find the value of sine 139 degrees. When you are given this question, the first thing you do is 139 degrees, in which quadrant is it? First quadrant has 90. Second quadrant has 180. Third quadrant has 270. Fourth quadrant has 360. Now, where does 139 fall into? If you look closely, you discover it falls into the second quadrant. Now, draw that second quadrant. Very, very important. Draw the angle of the second quadrant. That means the angle 139 is here. The equivalent angle you are looking for now is this theta. First of all, now ask yourself, sine in the second quadrant, is it positive or negative? Sine of this angle is going to be opposite over hypotenuse. Opposite is representing the positive side of the y-axis. Hypotenuse is always a positive. So we have positive dividing positive, which is positive. That means our sine, whatever value we are going to have for sine, is positive. Now come to the angle. The law applicable on the second quadrant is 180 minus theta, which is the same thing as 180 minus the angle that is given to us, 139. So use the calculator and find that value. It's 41. So this 41 degrees is the equivalent acute angle to 139 degrees. It is this acute angle now that you find its value from your four-figure table. I'm very, very sure that you know how to find angles from the four-figure table. Open to page 20-21, where you have sines of angles. So look for 41 under 0. 41 under 0 is giving us 0.6561. So I'm going to write plus 0.6561. That is the value of sine 139 degrees. Find the value of cosine 239 degrees. Just like the first question, ask yourself in which quadrant is 239. 239 has exceeded 180, but is not up to 270. That means it is in the third quadrant. So draw your third quadrant. This is the third quadrant. So draw a triangle. So this angle now, 239, is the angle from here to here. And its equivalent acute angle is this angle. So how do you find this equivalent acute angle? It's going to be the whole of this angle, which is 239, minus the angle from here to here, which is 180. So the equivalent acute angle there now is theta minus 180. And this is the law applicable in the third quadrant. You have not finished. You now ask yourself, cosine in the third quadrant, is it positive or negative? Let's check. This is the angle. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. The adjacent is representing the negative portion or the negative part of x-axis. The hypotenuse is always a positive. So negative dividing positive will give you negative. That means any value we find for this angle now will be negative. So let me put it up here. Now the law applicable here now is theta, which is 239 minus 180. Use a calculator and find that value, 59 degrees. Now go to your four-figure table. Open to cosines of angles. Page 22/23. Look for 59 under 0. 59 under 0 is giving us 0.5150. So we have minus 0.5150. So the value of the angle they're asking for, cosine 239 degrees, is minus 0.5150. Third question says we should find the value of tan 239 degrees. The first question you ask yourself, in which quadrant is 239? 239 is not yet up to 270, but it is more than 180. That means it is in the third quadrant. Show your third quadrant and draw your triangle for your calculation. This is the angle in question. And this angle is the angle from 0 to this place. The equivalent acute angle is angle of this triangle. You are going to derive it from the whole of this angle. Remember, this angle is 239. The whole of this angle minus the angle from here to here. That is giving us the law of theta minus 180 in the third quadrant. Now, in the third quadrant, tangent, is it positive or negative? Tangent is opposite over adjacent. Opposite representing the negative side of y-axis. Adjacent representing the negative side of x-axis. Negative dividing negative will give you positive. That means whatever value we have is going to be a positive number. Now let's apply the law of third quadrant. Theta minus 180. So we're going to have 239 minus 180. Use a calculator. 59. So this is giving us 59 degrees. Now go to your four-figure table. Open to tangents of angles. Page 24/25. Look for 59 under 0. 59 under 0 is giving me 1.664. So we're going to have plus 1.664. So this is the value of tan 239 degrees from your four-figure table. Find the value of tan 293. Ask yourself, in which quadrant is 293? 293 has exceeded 270, but it has not reached 360. That means it is in the fourth quadrant. So draw your fourth quadrant. This is your fourth quadrant, and this is the triangle on which you work with. This is your theta. That means this 293 is angle from 0 here to this place. If you want to find its equivalent acute angle, that means you have to complete this. The angle from here back to that place minus the angle from here to this place. That is going to give us 360, the angle of the circle, minus theta. The law applicable in the fourth quadrant. This is the same thing as 360 minus 293 degrees. 67 degrees. So the equivalent acute angle is 67 degrees. Now ask yourself, tangent, is it positive or negative in the fourth quadrant? Let's check. Tangent is opposite over adjacent. Opposite, representing the negative side of y-axis. over adjacent, representing the positive side of x-axis. Negative dividing positive will give you negative. So whatever value you get from your 4-figure table, that is the value of 67 degrees tangent, is going to be minus that number. So go to page 24/25. Find tan 67 degrees under 0. 67 under 0. Tangent of angles in degrees. It's giving us 2.356. So we are going to have minus 2.356 as the value of tan 293 degrees. Question number 5 said we should find the value of tan minus 220. This is a different conceptive, a different arena. The value of the angle is given in negative. Any negative angle given to you, the first thing you do is to convert it to a positive angle. And converting it to a positive angle is subtracting it from 360 degrees. So, minus 220 degrees is the same thing as 360 degrees minus 220 degrees. That is the first thing you do. (360) minus 220, 140. That means minus 220 degrees is the same thing as plus 140 degrees. It is now this 140 that you apply the normal principles we have been working on. First of all, ask yourself, in which quadrant is 140 degrees? 140 degrees is in the second quadrant. So draw your second quadrant. So this is the triangle of your second quadrant. And this is your theta. Now, ask yourself, in the second quadrant, remember this is tan. Tangent, is it positive or negative? Tangent is opposite over adjacent. Opposite, the positive side of y-axis. Adjacent, the negative side of x-axis. Positive divided negative will give you negative. So whatever value you have will be a negative. Now, what is the law applicable in second quadrant? The law applicable there is, if the angle you are looking for is this angle. Now, to get its equivalent acute angle is the angle from here to this place minus the angle from here to here, which will give you angle from here to here, which is 180 minus the theta. So the law applicable in the second quadrant is 180 minus 140. 180 minus 140 is going to give you 40. So we are going to look for the tangent of 40 in the 4-figure table, and whatever value it gives you, write it after this negative. Tan 40 under 0. 0.8391. 0.8391. That means tan minus 220 degrees is having the value of minus 0.8391. Question number 6 is a unique question also. It says you should find the value of theta in cosine theta is equal to 0.9703. When you have this type of question, they have given you the value of theta from the four-figure table. Just go to the four-figure table, open the cosines of angles, and look for this number. If you look for the number 0.9703, I got it at 14 under 0. I will come to the camera and show you where I saw it. So what I got is 14.0, 14 under 0. Now, that means that the value of theta is 14.0. But you will not leave it like this. Remember, cosine, the value of that cosine is positive. Since there is no sign written before the number, that means it is positive. Now ask yourself, in which quadrant is cosine positive? Cosine is positive in the first and fourth quadrants. You can see you are cast. All cosine, tangent, sine. It is in the fourth quadrant that cosine is positive, but also positive in the first quadrant because all the trigonometrical ratios are positive in the first quadrant. That means the first quadrant has no law. 14 is one of the values. 14 degrees is one of the values. Now, in the fourth quadrant, what is the law applicable in the fourth quadrant? The law applicable in the fourth quadrant is 360 minus theta. So equate 360, the law of the third quadrant or fourth quadrant minus theta is now equal to 14. Which was the figure you got from the fourth figure table that is connected to 0.9703. Do this arithmetic. You're going to have minus theta is equal to 14 minus 360. Minus theta is equal to, use your calculator. What this means is whatever you have is minus. Subtract 14 from 360. 10 minus 4 is 6. This will remain 5. 5 minus 1 is 4. Bring down 3. If minus theta is minus 346, that means only theta is equal to 346 degrees. Now, the two values of theta for which cosine theta is 0.9703 are 14 degrees and 346 degrees. They are the two values that will make theta, the two values of theta of which cosine theta will be plus 0.9703. This is now question number 7. It says if you find the value of theta in sine theta is equal to minus 0.4939. Go to your four-figure table. Open the sines of angles. Look for this number. Look for 0.4939. 0.4939 I could find at 29 under 6. Let me come and show you this as an example. This is the four-figure table, page 20/21. On top of it, you see sines of angles x in degrees. Okay, we are looking for 0.4939. Horizontally, look at it. 4939. So horizontally, it is on 29. Vertically, it is on 0.6. So the angle we are picking there now is 29.6. All right. So the value we have there is 29.6 degrees. The next level or stage of the question is, in which quadrant is sine negative? In which quadrant is sine negative? Sine is positive here because all the trigonometrical ratios are positive here. And sine is positive in the second quadrant. That means on the third and fourth quadrant, sine is negative. We are going to apply the laws in the third and fourth quadrants. What is the law applicable on the third quadrant? The law applicable in the third quadrant law says theta minus 180. So theta minus 180, you're going to equate it to this number you found from your four-figure table, 29.6. Now, that means theta is going to be equal to 29.6 minus 180, coming across with change to plus 180. Theta is going to be, it's giving us 209.6 degrees. That is one of the values of theta, for which sine theta is minus 0.4939. The second one is that sine is also negative in the fourth quadrant, and the law in the fourth quadrant says 360 minus theta. So 360 minus theta will be equated to 29.6. That means minus theta is equal to 29.6 minus 360. Let's subtract. What this thing means is minus theta is equal to whatever you have by subtracting 29.6 from 360. It will be a negative. It's given me 330.4. If minus theta is minus 330.4, that means theta is equal to 330.4 degrees. Now it means the two values of theta for which sine theta is minus 0.4939 are 1, 209.6 degrees. And the second one is 330.4 degrees.